In this video, we'll be looking at balancing of this redox equation under basic solution. What you need to do is to add hydroxyl and water. Anyhow, if you have not watched our previous video on balancing of redox equation under neutral and acidic solution, we advise you to do that. If you have time, if you will, but it's important to get the whole full gist of what we are saying. Now, under the basic solution, which is the prerogative for today's class, stay with us. We're going to get something from it. Now, you have that. The first thing is to divide the equation into two halves. We have potassium, gives you potassium hydroxide. Now, I have 4 hydroxyl here. What I'm going to do is to add 4 hydroxyl to the other side. 4 hydroxyl. Now, the hydroxyl is balanced, the potassium is balanced, but the charge is not balanced. Now, I have -4 minus 1. Minus will cancel minus is 3. Now, you add 3 electrons to the side with the highest charge. -1 and -4, which one is higher? -1 is higher than -4. Do you know that? Okay. So, we have potassium plus 4 hydroxyl. You're going to give me potassium hydroxide plus 3 electrons. Let's call this equation 1. Now notice that the ions are balanced. -4, 4 times 4, -4. -1 plus -3, -4 is balanced. Let's go to the next one. The next one is sulfur. Sulfur gives us sulfur. Now what you need to do to balance this oxygen in this basic solution, if you first start off with balancing under acidic solution and then proceed to basic solution. So what we do is that let's add 4 molecules of water. 4 times 1, that is 4. We balance out the oxygen molecule, that is 4 here. Alright, but we have a problem with hydrogen. 4 times 2, that is 8. I'm going to add 8 hydrogen to this side. Alright? So, now, the next thing now, we are balanced. This is just a step to balance on the acidic solution. Let's move on to basic solution. Under the basic solution, we are going to be adding hydroxyl. So, 8 molecules of hydroxyl to this side. What you do on this side, you do on this side. 8 molecules of hydroxyl here. So what I'm going to have is that this will form SO4 minus plus 8H2O, which will give me sulfur plus 4H2O, and then plus 8 hydroxyl. Now, if we look at this equation, we have 8 molecules of water, 4 molecules of water. If you subtract from here, okay, I need to see what I'm doing. Let me bring out this equation to this side. Let's say we have SO4 minus plus 8H2O gives me sulfur plus 4H2O plus 8 hydroxyl. Now, if I subtract 4 molecules of water from here, I have to subtract 4 molecules of water from here to reduce this equation. So what I'm going to have here is SO4. 8 minus 4, that is 4H2O. Let me get the rest up. 4H2O. And then I have sulfur. This is out now, 8 hydroxyl. Alright, so but the elements, sulfur 1, good. This is sulfur, not 5. Water, oxygen is 4 plus 4, 8. 8 times 1, 8. Hydrogen, 4 times 2, 8. 4 times 1, 8. But the charges, -1, -9. Minus 8 plus -1 is -9. You see that? It's not balanced. So -1 minus -9. This will cancel. Okay, that will give me 8. Alright? So we'll add 8 electrons to the side that have the highest charge. Let's confirm this with the calculator. -1 minus 9, 8. Correct, it's correct. Alright, that's correct. We'll add the 8 to the side that have the highest charge. -1 and -9. Which one is higher? -1 is higher than -9. Alright, we have SO4 minus plus 4H2O plus 8 electrons. So I'm adding 8 electrons to the side with the highest charge, which will give me sulfur plus 8 hydroxyl. So the next thing to do is to equalize the equation. Let me call this equation 2. Equalize the two half-side equation. This is the first half-side equation, equation 1. Second half cell equation. What I need to do now is that I will find the LCM between the two. The LCM between these two equations is to multiply 8 by 3. If you multiply 8 by 3, that is 24. So what I'm going to do here is I'll pick up this equation, multiply it by 8, pick up this equation, multiply it by 3, so I can cancel out the electrons. Let's go. X times by this, now to give me 8 LCM of equation 1 and 2. That's what we're writing now. X times by this, now will give me 8 potassium. X times by 4. X times by 4 should be 32. 32 hydroxyl. Okay, X times by this guy, 8 potassium, hydroxyl, minus charge. X times by 3, this is exactly what I want, 24 electron. Let's call this equation 4. Alright, let's do the next one. The next one is we're multiplying this guy by 3. 3 times by this guy, we're multiplying this equation 2 by 3. So we multiply this by 3. 3 times this guy, we make a space here. So 3 times this guy, 3 SO4 minus 3 of those. 3 times by 4, that is 12 of those, 12 H2. Then 3 times by this guy, that is 8 electron. Sorry, 3 times by 8 now is 24 electron. Then 3 times by this guy, that is 3 sulfur. 3 times by this guy, 3 times 8, that is 32. Plus 3 times 8, confirm that should be 32. Let's confirm that please. 3 times 8, 24, sorry. So we have 24 hydroxyl. Okay, let's call this equation 5. Now, having done that, we need to understand that we have 32 hydroxyl here, and we have 24 hydroxyl here. Can we simplify the equation? Yes. Let's subtract 24 hydroxyl from here. Let's subtract 24 hydroxyl from here. Now notice that the 24 hydroxyl will die at the reactant side. But at the product side, 32 will minus 24. Let's see what we'll have as the product. Let's do that. Let's should I actually not the board? Yeah. So what I have now as my new equation, let's start off from here. I have 8 potassium plus 32 minus 24. Let's do that. 32 minus 24. 32 minus 24. Minus 24. That is 8. Alright? I want to be sure. That's what I'm taking. It's 8. 8 hydroxyl. Alright? Now let's do we have resolved this. Now the next thing is what do we have on this side? What we have on this side is plus 3SO4 minus, what do we have here? We have plus 12H2O. What do we have? Nothing, because electron will cancel out electron. Alright? Electron will cancel out electron. 24 minus 24 is off. So this will give me now 24 electron will cancel out 24 electron. 24 hydroxyl will be subtracted 24 from here, so that this will reduce to 8. While this hydroxyl will die, these electrons will die. You get that point? Alright. Now let's take the reactant side. What we have should be 8 potassium hydroxide. Is it that? Yeah. Now let's look at what we have again on the product side. We have sulfur. Plus how many? 3 sulfur. Alright, this is the balanced equation. Now let's check whether the equation is balanced really. 8 potassium over there, 8 times 1, 8. Let's go to the sulfur. 3 times 1, 3. 3 times 1, 3. Remember there's a minus charge here. Alright? Now let's go to the hydrogen. 8 times 1, that is 8, plus 12. potassium is 8. 8 times 1, 8. Now, hydrogen. Hydrogen is 8 plus 24. 8 plus 24, what's that going to be? 8 plus 24, that is 32. So hydrogen over there is also 8 times 4. 8 times by 4. That should be 32. 8 times 4, 32. See that? 32. Then let's go for the oxygen. Oxygen, 8 times 1, 8. 3 times 4, I think that's 12. 12 times 1, that is 12. Add all this together, it should also be 32. Now over there, 4 times 8 times by 8 times by 4, that is also 32. Now you can see that the oxygen, the hydrogen, the potassium, the sulfur is balanced. Let's check for the charge. Minus 8 plus minus 1, that is minus 9. Over there, minus 8 plus minus 1, that is also minus 9. So this is how to balance the basic solution using the balance the redox reaction under the basic solution. So I have an assignment for you. So I have that you can solve this to aluminium plus perchlorate gives me aluminium hydroxide. Alright, plus chlorine. Now you can try this part. Then you drop the answer. Try out this question, and then you drop the answer on the comment section below. This is all we've got for you. See you soon.